So beginning with the webinar, basically the second series of the whole session, which will be container orchestration. So before starting off, in the last session, we talked about Docker containerization and discussed what exactly containers are, what are virtual machines, how they are different from each other, what is Docker, and took a look at the fundamental workings of how Docker works. We concluded that webinar with a small demo showing how you can Dockerize a Python application which runs a script, and basically you change colored images to grayscale using the Docker containers. Now moving on with today's session, what we'll discuss is what is meant by container orchestration, the different types of orchestration frameworks that are available. We'll be discussing three of the more prominent ones and how they work. We'll then have an overview of the Azure Container Service and how it will ease the daunting process of orchestration by abstracting the inner workings and allowing the user to focus on the tasks that truly matter. So moving on, this would be the agenda. Diving right into the first thing, which is what is orchestration? So moving on into what is orchestration. So the Docker platform and the surrounding ecosystem, it contains many tools to manage the life cycle of a container. One example is the Docker command line interface, which supports the following container activities, such as say pulling a repository from the registry, running the container, and optionally attaching a terminal to it. Say you're uploading an image to the registry, or lastly, finally, you're done with your whole application and then you're terminating the running container. Now the CLI meets the needs of managing one container on one host. It will fall short when you have to manage multiple containers which are deployed across multiple hosts. So to go beyond the management of individual containers, what we need is you need to turn to the orchestration tools. So by abstracting the host infrastructure, orchestration tools will allow the users to treat the entire cluster as one single deployment target. Orchestration tools extend the lifecycle management capabilities to complex multi-container workloads deployed on a cluster of machines. In simple terms, what we can say is container orchestration is basically the automated arrangement, coordination, and the management of your software containers. Say, let's go through an example. Say you have your current software infrastructure, which may be something like a Node.js app or a Python app, which is running on a few containers that is communicating with a database. Now, for such type of an infrastructure, you might not require container orchestration. You can probably manage everything on your own. But what if your application keeps on growing? What if you're adding more and more functionality to it until it becomes so massive that it's impossible to maintain and it eats up way too much of your CPU and your RAM? So what you do, you decide to split your application into number of small chunks, each one of the chunk responsible for a particular specific task, which is maintained by a team. This is the concept of microservices. So now, say you want to add more functionality to it. You want to have high availability, you have to increase the performance, you want to process the tasks which are asynchronous, you want to quickly share your data between the services. You might even want to have multiple instances of your microservice to make it highly available. So with all of these come challenges. Challenges such as load balancing, storage management, health checks, automatic scaling, having zero downtime. This is where your container orchestration becomes extremely useful and powerful, because what they're doing is, everyone able to hear me, or are there still problems going on?
We are able to hear.
Okay, so I'll continue. I suggest you might need to rejoin, Joseph. So continuing. So container orchestrations, they are extremely powerful, they're extremely useful, and they are a solution to basically all of these management and deployment challenges. Containers allow us to standardize the environment, and they help you abstract the underlyings of the operating system and the hardware. So think of a container orchestration as doing the same thing as at a data center. The user, he does not need to be concerned with how the container is monitored, how it has started, how it has been killed. Moving on. We'll go on to the orchestration frameworks. So while the container format, it is largely settled for now. Now the real differentiation is how you can deploy and manage those containers. So even though we'll be talking about the three more prominent options that are available right now. First one being the Docker Swarm, second the Kubernetes, and the last one the Apache Mesos. All of them, they do container orchestration, but each framework's approach and the features that it offers is different. We'll start off right with Docker Swarm. So the objective of Docker Swarm is to use the same Docker API that works with the core Docker engine. The key advantage to this particular approach, all of your existing tools and the APIs will continue to work with the cluster in pretty much the same way that they work with a single instance. It uses your standard Docker API and networking, and it makes it easy to drop into an environment when you're already working with Docker containers. Docker tooling, the command line interface, and the Docker Compose are how your developers create their applications, and therefore they don't need to be recoded to accommodate an orchestrator. See, let's go through the diagram on the right hand side of the slide. So over here, an overview of the workings of the Docker Swarm would be, you have the Docker client, which is basically the UI that the end user communicates with, which is installed on the user's machine, and it communicates with the Docker manager. The Swarm manager, now this is the brain of the whole operation. The Swarm manager orchestrates the deployment, the replication, and the availability across the Swarm nodes. The Docker client connects to the Swarm manager, which further orchestrates the nodes and makes it look like all of the nodes are running as a single host. Docker nodes, they are the workers. They do all the hard working. The manager abstracts the underlying workings of the nodes. You can use a Docker client, you can connect to a Swarm manager. The Swarm manager in turn can connect to a Docker hub, get a preset image from its repository, and then deploy it onto the Swarm nodes. Moving forward, we'll have an in-depth explanation. So we'll go through the key concepts of Docker Swarm. The previous one was just a high-level overview, but it consists of a lot of many more functioning parts all glued together. So we'll be talking about, first there's the Swarm managers. They are the nodes. As I mentioned before, they use the Docker API and they access the Docker daemons, which are in the Swarm nodes. Nodes are added to the Swarm manager using something called as a discovery service. Now, discovery service has in itself a set of three functions, one of which is the fetch, which basically gets you the list of nodes. Swarm nodes are runtime instances that represent a node. They talk to the actual host using a Docker Go client. Then there's a scheduler. Now, a scheduler is basically responsible for scheduling a container that is on a node. It has a pluggable architecture, and there are multiple strategies that are associated with a scheduler. Docker Swarm in general has two. One is the bin packing and one is the random strategy. So the bin packing strategy, what it does is it ranks your nodes using the CPU and the RAM available, and it returns the node that is the most packed. The random scheduling strategy basically chooses a random node, and it's mainly used for debugging. Then there is something called as a swarm store, which stores the state of the cluster. The state is loaded in the memory when the cluster starts. Lastly, we have the discovery service, which helps your swarm manager discover the nodes. You have three functions associated with it. One is the register, one is the watch, and one is the fetch. It also uses a pluggable backend architecture, and it works with a simple hosted discovery service. For many, it is a plus, considering that not only is Docker Swarm container centric, but rather it is Docker centric. Docker Swarm gives you an easy way to move into container orchestration without leaving behind the familiarity of the existing Docker tools. It is an orchestrator that makes it look like the whole container infrastructure is one complete unit. So any Docker compose that you provide to the Swarm will take care of the allocation, the distribution, the health monitoring, everything that the end user would need to worry about. But Docker Swarm isn't the only player out there. It has natively grown in the Docker environment and raised in Docker tooling. Those are the pros that it offers. Next, we move on to Kubernetes. Now, Kubernetes is based on Google's experience of running workloads at high scale in production over the past 15 years. So it enjoys high credibility. Docker Swarm extends your single host Docker, whereas Kubernetes, the main focus of the whole framework, is the cluster itself. No doubt, Kubernetes is geared towards mid to large scale clusters. So the learning curve and the setup is definitely more taxing than the Docker Swarm, but the payoff comes off when you need the flexibility and the sustainability for larger scale deployments. The key concepts of Kubernetes. The main parts that make up the Kubernetes cluster is you have a master which handles all of the API calls. You assign the workload and you maintain the configuration state using the master. Then you have the minions which serve. Now these are the workers similar to the ones found in Docker Swarm. They're called as servers and they run the workloads and anything else that's not on the master. Next you have the pods, which are units of compute power, and they make up one or multiple containers which are deployed on the same host. Together they perform a task. They have a single IP and flat networking to communicate with the other pods. Next we have the services. The services basically are the front end and the load balancer for the pods. They provide a floating IP to access the pods. Changes happen at the pod level interface, maintaining a stable connection. You have something called as the replication controller, which you can see as part of the master, and it is responsible for maintaining supposedly a number of n replicas of your required pods. Lastly, we have the labels. Labels are nothing but key value tags. Example, the name that you can assign to identify the pods, the replication controller, the scheduler, the services, everything. Moving on, just a brief summary on Kubernetes. It's well suited for medium to large clusters running complex applications. Now, Kubernetes already, as you've seen, diverges from the Docker swarm. The CLI and the API are different to Docker, but there is a massive community support behind Kubernetes. Means it has an active language specific libraries and other integrations added to it at all times. The modularity is extended to the containers themselves. Kubernetes is not a Docker only show. While it might be inconvenient if you're already familiar with the Docker tooling, it leaves you the possibility of using other container formats. Lastly, we'll go through to Apache Mesos. Now, Apache Mesos is an older orchestration framework, even which predates Docker. It has been raised in the big data world, and it is used by Twitter and Airbnb, just to name a few of the big tech giants. Moving on to the key concepts that make up the Apache Mesos. So a typical Mesos cluster will consist of one or more servers which run the Mesos master. And you have a cluster of servers which run the slave component. Each slave is registered with the master to offer the resources. The Mesos master service runs on the master node and manages slave daemons. The slave daemons, the Mesos slave service runs on each of the slave node, and you run the tasks that belong to the framework. Now there is something called as offers. Offers is a list of a slave's resources. So each slave node will send its offer to the master, and the master will provide that offer to a registered application framework. A framework is nothing but an application definition. It consists of a scheduler, and it registers with the master to receive the offers and then branch out the particular task onto a slave. Lastly, we have the Apache Zookeeper. Now the Zookeeper is the software that is used to coordinate the collection of your master nodes. Unlike other tools, Mesos ensures high availability of the master nodes using the Apache Zookeeper. So you replicate the masters and you form a quorum. A high availability deployment would require at least 3 masters. All the nodes in the system, including the master and the slave, communicate with the Zookeeper, and they determine which master is the current leading master. The leader will then perform the health checks on all the slaves, and it will proactively deactivate anything that fails. Mesos is designed to scale to hundreds of thousands of nodes. The setup is more complex compared to Docker Swarm, and the learning curve is steeper. But Mesos has been around for such a long time that it has had time to knock off all of its rough edges and is a proven runner in the real world situation in the massive scale. Next, we'll go to the summary of the 3 orchestration frameworks. So the 3 options that we considered, they vary considerably in implementation and in how the user interacts with them. Docker provides the easiest route there is into orchestrating a cluster of Docker hosts. You have Kubernetes, which is container centric and focuses less on the containers but more on the deploying and the managing of services. Lastly, you have Mesos, which promises huge scale but introduces additional complexity with it. Moving forth, we'll go through an overview of the Azure Container Service. Now, Azure Container Service are an easy to install, best practice, scalable approach for deploying your containers in the cloud service provider. Azure provides a template for the users who have absolutely little to no knowledge of containers, and then it follows it up with the best practices in terms of security, scalability, and functionality. Azure Container Service uses the Docker Swarm, the DCOS, or the newly added Kubernetes to orchestrate the deployment. Now, DCOS is nothing but based on the Mesos orchestration, and it's a simplified container-focused version that's easier to get into and implement. Orchestrators. So Azure Container Service in combination with the resource manager will set up the whole infrastructure for the end user. Mesos and Kubernetes, now they are more complicated than the Docker Swarm, and the end user would need to know the functioning components of the model. That was the thought till date, but practically it's not so anymore because Azure Container Service makes it easy. It has made it accessible since it is taking care of the whole backend setup. It has active support from Docker, Kubernetes, and Mesosphere, and is following the best practices that is coming directly from the experts. Users comfortable with Mesos and Kubernetes will still be using the same services, with just Azure running the backend. Well, that would be my session on container orchestration. Thank you so much for joining me in this session. And if you have any questions, feel free to put them in the chat window.
Right. Thank you very much, Aman. So unless you have any questions, guys, please type them in the chat window. If not, so we would continue this series with the next one where we would demonstrate setting up the Docker container using Kubernetes on Azure and also the DC. That way you'd have an option and see how it works in Azure environment. So with that concludes our session here. The next one is anyone who joined the session have option to leverage our Azure Everywhere free assessment. Cloud9 is a Microsoft Gold partner with expertise in cloud and data analytics areas. So you could leverage this assessment where we would help you understand to focus on your business infrastructure or your migration or your cloud strategy or your data strategies. So you can reach out to Bert Parekh, he's our VP, with regards to any of the assessment requirements.